Okay. Taking a look at number 32 here. So Riley plotted the points, and she wants to form a quadrilateral. We want to prove it's a trapezoid. We talked about in class, we need to make one pair of sides, so like two sides that are across each other. The opposite sides are going to be parallel. So if we do -1, 6 is point A. We had 3, 8 for B. C is 6, -1. And then D was 1, 0. So when we're doing these figures, and just like during an exam, you'll have a straight edge to use for your purposes of at least drawing lines. Not allowed to measure them, but it's just used to draw straight lines. So keep that in mind. All right. And then we talked about in class the way you can figure out the slope. First of all, what two lines do you think are going to be parallel here based off of how they're drawn? And then you can just count the rise and the run on the graph or use the slope formula. So we'll kind of just review that real quick here. So there's our figure. Remember the slope formula is y2 minus y1 over x2 minus x1. And then all we're basically going to do for this question here is you can just use the rise and the run on the graph to write down. So if you're counting from A to D, we're going down and then right. So it's +2 to the right, that's the run, and then 2, 4, down 6. So we could say the slope of AD is -6 over 2, which is -3. And then the slope of BC, which is the line that's going to be parallel to it, is going over 3 to the right, and then down, or you can think about it going up and left, it doesn't really matter, down 9. So once again, -9 over 3 is also going to equal -3 here. And we are running into some lag errors there. All right, hopefully you guys can still see okay. So -9 over 3. Okay. Or you can connect a line from A to C. We can then draw ourselves like a right triangle here, connecting those two lines. So we're going down 7 and then over 7, and then we can use Pythagorean Theorem. So 7 squared plus 7 squared is equal to c squared, and that'll give us the length of this line, AC. This is 49 plus 49, so that's 98. And then C is going to equal the square root of that. So that is the distance of AC. And then we have the same idea here with the distance from B to D. So if we were to draw a line from B to D, and then we could draw ourselves the rise and the run to make a right triangle. Okay, this distance that we're traveling down is 8, and then we're going over 2. So if you do Pythagorean Theorem, 8 squared plus 2 squared is equal to c squared. That's 64 plus 4, so 68. And then the square root of that is going to equal c. And so that is the distance of BD. Okay, and then we could say that AC is not equal or congruent to BD. Okay, because the distances are not equal. And then once we know that, we can say that it's not an isosceles trapezoid. Okay, so then A, B, C, D is not isosceles. Since the diagonals are not congruent. All right, and then that was that 32. Okay, so if we pull up the grading rubric for 32, all right, so correct work is shown. That's trapezoid, not an isosceles trapezoid, including concluding statements. So you have to make sure you're saying that part about it being a trapezoid because the lines are parallel, and not being isosceles because the diagonals are not equal. If you made a computational graphing error, so maybe you graphed a point in the wrong spot, or you did a square root but got the wrong number, okay, or added wrong, or whatever it was, if you're missing a concluding statement, one of them, okay, or it's incorrect, you lose a point. If you make 2 or more graphing errors, you're down to a 2. If you've shown it's a trapezoid and have a concluding statement, you got a 2, okay? If you got the isosceles, it's a 2. And then if you make 2 or more errors and one concluding statement is missing, so you can kind of get the idea that like the concluding statements are worth a 2 point, like a point each. As long as you do one or the other, you get 2 points. So that's essentially what's going on. But and you can get points just for finding the slopes, okay, or showing it's not isosceles. So there's a couple ways to give points here, but this one wasn't too bad. You should have been able to get this one on your own, hopefully, if it does pop up on the exam in the future here. So, all right, let's take a look at number 33. So this is the next one. A child-sized swimming pool can be modeled by a cylinder. The pool has a diameter of 6.5 feet, height of 12 inches. The pool is filled with water to 2/3 its height. Determine and state the volume of the pool to the nearest cubic foot. And then it follows up with, if 1 cubic foot equals 7.48 gallons of water, determine and state the nearest gallon, the number of gallons in the pool. And that would be it for this question. So, any problems that we're noticing when we look at this question?
They're not all one measurement, like there's feet and inches.
Nice, good. So we have 6.5 feet, right, and 12 inches. Now the key thing when you want to know which to use is look at what they want our answer in. So it says nearest cubic foot. So that tells me that I want to get everything in feet, okay? So always look to this like end result and see what that needs to be, and then we can convert into it. So pretty easy if you want to draw ourselves a picture. We got ourselves, okay, a little pool here. The height of it was 12 inches, which is 1 foot. So that's the height. And then the diameter is 6.5. So that's going all the way across. So we got to keep in mind that the radius then is going to be 3.25. All right. And this is another one. Some people would have lost credit on this question because if they didn't pay attention to the fact that we're filling it only up to 2/3 of its height. So although, right, the pool is 1 foot high, the actual height of the water that's in there, okay, is actually just 2/3 of a foot. So now we can calculate the volume. All right, and this formula, remember, is on the formula sheet, so you can always tear that off to start your exam. Highly recommended that that's what you do. All right, tear this page off, the graph paper, keep it right next to you so that you have it if you need it. All right, and then once again, cylinder formula for the volume is pi r squared h. So pi r squared h, and then we're plugging in. So pi, the radius is 3.25 squared, and then the height we talked about being 2/3. Now it says nearest cubic foot, so we are going to use the pi button on the calculator. So we can grab that. Okay, so pi. All right, 3.25 squared. And then you can do times. You can either do 2 over 3, or remember, control divide brings the fraction bar into play. All right, and if you do 2/3 like this, that's fine as well. If you want to just do the division bar, it does do order of operations for us, so it's still going to bring it there. And then we're rounding to the nearest cubic foot, so that would be 22 cubic feet. Okay, so we can use this answer now to do this part down here. So if 1 cubic foot equals 7.48 gallons of water, what to the nearest gallon, how many gallons are in the pool? So all we have to do for this one is take 22 and multiply it by 7.48 to get our answer. Okay, and we're just going to check here. Okay, is going to be 165. If we do use this answer, it's still going to be 165. So even if you use the original or the rounded answer of 22, you're still going to get the same thing. So it's not going to throw anything off here. Okay, but once they've asked a question and you've answered it, the second part you can use that answer. So this is going to come out to be 165.4 and change. So we just got to make sure we answer though to the nearest cubic foot. So gallons. So there's 165 gallons. Now, I know we can't see the screen necessarily, or that I'm writing a little bit higher than what it should be on the exam for all intents and purposes here, but when you're doing this one and on the exam, all right, is put that underneath the section where it's supposed to be. Okay? And then we can go over to our rubric again. So 22 and 165 with correct work out of 4. If you made a computational or rounding error, that means if you were to round, okay, up here somewhere, or if you use 3.14 or something else up here, there's an issue there as well, okay? If you made 2 or more computational errors or rounding errors, or if you made correct work to get 22 and you didn't do anything else, that was a 2. They also have what's called a conceptual error. So if you had used, for example, 6.5 instead of 3.25, or if you used 1 instead of 2/3, like that would have been a half credit deduction here as well. Okay, and then once again, you only get a point for stating the answers with no work. So make sure we're always showing work to get full credit. All right.
I have a question about this.
Sure.
So if we find the answer correctly, but find the incorrect answer, would it be 0 credit automatically, or would we get some point for correct work?
So when you say you found the correct answer or incorrect, so like if you got this part wrong?
Yeah, so say we showed correct work, we just used wrong numbers or something
Sure.
like that, but we still showed the correct step-by-step process.
So if you did let's say we put it depends on what your error was here, Charlotte. So if you, for example, use the correct numbers, but let's say we rounded wrong and we put 23 instead of 22, right? This is a 1 point off, and then you carried the 23 through and got the correct answer here. That would be worth 3. Just a point for this. If that makes sense.
Yeah.
Okay. So usually the way that we kind of interpret these, especially when we look at the rubric, is seeing essentially what the value is for each part. So to get 22 gives you 2 points, and that means the 165 is essentially worth 2. So As long as you get one or the other correct, right, you're getting 2. So if you mess up here, but this part's good, depending on what you did, you could still get 3 or 2. All right, like I said, if you're making a thinking error that's conceptual, like using the 1 or using the 6.5, then that's a half credit. All right, 34. Nick wanted to determine the length of one blade of a windmill. All right, pictured below, he stood at a point on the ground that was 440 feet away from the windmill's base. Using surveyor's tools, Nick measured the angle between the ground and the highest point. The blade was 38.8 degrees. He also measured between the ground and the lowest point on the top of the blade and found it was 30. Determine and state the blade's length to the nearest foot. So we want to know what this is. So, any ideas?
Use Sohcahtoa with a 30-degree angle to find the opposite angle to 30.
Mm-hmm.
And then once you have that, you can use Pythagorean Theorem on the other side, and then you can use that for the other triangle.
Okay, good. So good, Yassine. So that's one option, right? So if we were to figure out, there's a couple different ways we can kind of do this. What I would probably suggest is, because this line is cutting through the triangles, right? This line right here that cut through from the blade, how many right triangles do we see? So this is one of the triangles right here, right? And there's 2. There's another one. There's also this one going all the way down. Okay? And since we essentially have, right, both of the angles here, right? We have this whole angle, and then the smaller triangle. Oh, it changed it on me to blue, huh? We have this whole angle. All I need to do is figure out what the heights are for both of them, and then we can figure out what the missing part is. So, Charlotte, you mentioned finding a different angle.
No, using like the 30-degree angle to find like the other sides.
Okay.
Yeah.
Gotcha. Yeah, that would be an option too. So if you found the other sides and then use Pythagorean theorem, you can also do law of sines, but that gets a little bit tedious here. Really, you don't need it to be more exact. So it's just going to convert this to red here. Maybe it'll let me. Close enough. All right. So in the red triangle, right, we have a 30-degree angle, and the ground is still 440 here. So if we can figure out what this side is, we can call this X. Well, we already have an X. Don't use that same letter. We'll call this H. That's what this part is right here. And then if we figure out what this entire, right, height is over here, maybe it'll let me pick it. We'll find out. All right. We'll call that F for the, or we got windmill. We'll call it W for the windmill. Then we can just subtract them to get X. So if we take a look at the small triangle first, you guys mentioned we're using Sohcahtoa. So if we write that out for ourselves, all right, and then we're going to essentially pick our angle, label our sides. So the 440 is adjacent because it's next to the angle. H is the opposite. We don't know the hypotenuse, so we're not using that one. So that means we're going to be busting out some tangent. So to get H, the tangent of the angle, which is 30, okay, is going to be equal to, just fixing that 3 there, the opposite leg, which is H, over the adjacent, which is 440. And then we can just cross multiply and solve. Remember, looking for a side, we're going to cross multiply. So 440 tangent of 30. And then we want to write this out to a few decimal places. I would at least take it 3 or 4 places out. So when you grab your calculator, make sure it's in degree mode. It should be in that for you already, but just double check. All right, and then we're going to go ahead and do 440. Okay, trig, tangent 30, enter. There's our first answer. So we'll go 254.0341. So 254.0341 for that length. I'm just double checking. Okay, good. That's this height right there. And then we're going to do the W part. So if you're looking at the big triangle going all the way up and down, same thing with the right angle. This is 38.8. This is still 440. And now we're looking for this side. So once again, you can see already that we have the same setup. We have the adjacent here and the opposite. So we're still using tangent. So the tangent of 38.8 is equal to W over 440. Cross multiply again. All right. And then we can just go ahead and bring that down, change that 0 to an 8. 343.76. We'll go 57. All right. And then X is going to equal the W part minus the H. Okay. And then we can either just write our abbreviated forms in here so that anyone that's grading our paper is going to understand what we're doing to get our answer. And then you can just state your final answer when you're done. I'm just going to bring this down. Just so we're building. I got room down here, so I just want to make sure we have everything there. And then remember, on the calculator part of things, what we're actually going to do is go up and choose the whole decimal here, because we don't want to do the rounded version on this question. Okay, because it's still part of the same question. And then we get, and make sure we don't lose points by getting something wrong because of the rounding. So when you're done, double check the question, right, to the nearest foot. So that would be, according to my question, 89.7 should give me 90 feet. Okay. All right. And if you want to state in words, the blade, you can, is 90 feet long. Just make sure we're, consistent in putting our answers and we're not rounding incorrectly there. Okay, and then once again, if we take a look at, oh, they got 100. Let's go back and take a look. What did we do wrong? From the ground. Sometimes there's like an extra little piece that we forgot to add in. I am getting. All right, let's check. Did we just write the number wrong? Tangent 30, tangent 33.8. Oh, I see what we did. I forgot the 0.8. Fail. Teacher fail. So it's 38.8. I just put 38 in the calculator. Oh man. But so that on my part would be a calculation error because I wrote, if you're writing down, so that's why it's important to show work. If I'm writing down the work here and this answer is wrong, that's calculation error. So instead of being a 2-point deduction, that would be 1. Let's go back over here and do this again. 38.8. All right, there's our 353. There we go. And there's our answer. So 99.7. Okay. Took us a second to realize where we went wrong. All right, and so then it is 100 feet long. All right. Okay, any other questions on this one? Are we okay to move on? All right, so a couple other things that we can notice here. Good to go. Just looking at what we did. So computational error is 1. If you found the height of the to the bottom of to the top of the blade and the height to the top of the blade. So if you found the 2 heights correctly, but you didn't do anything else, that's 3. If you have 2 or more computational rounding errors or a conceptual error, which would be like using the wrong trig function, any one of those things would be a conceptual error. Or if you labeled the wrong side or anything like that. If you found the height to the bottom of the blade or to the top of the blade, so if you found either R, H, or W, you would have gotten 2 there as well. All right. All right, let's go to the next one here. So, final question is a proof. So, what type of proof, Maggie, are we looking at here? What do we need to do? Yes, similar triangles. Awesome. Very good, Asim. Nice. So here's the deal. Because we're looking at these side lengths and there's a bunch of triangles, we want to figure out what the triangles are first. So use these side lengths to identify them. So we have TA, so we're going to trace over TA. We have HA, we can trace over HA. Okay. We have HE, and we have TH. So what triangles involve those sides would be our question. Right? And it looks like we have one right here. And then what's the other triangle we think that we're going to have to get? Good. HTA and HEA look like they're the correct ones. These are right here. All right. That's awesome. So, get over here more. There's Kate. Say hi, Kate.
Hi.
All right.
Hi.
Okay. So there's this one right here. And then the one on this side. Now we can go through and kind of label everything up top. So we know, remember, in order to make this happen, we got to think about what we need to do. The first thing we need to do is get the triangles to be similar. The second thing we need to do is make a proportion so that when we cross multiply, we get here. Okay? So, and then the third thing we're going to need to do is do that proof statement. Okay, so before we begin, let's do our T-chart here. Let's try to make some straight lines, though. There we go. All right. remember, no points for the t-chart, the statements and the reasons. However, not having them is not, you're going to lose a point. All right? So make sure we are making sure that we do that every time to start with. And then if you don't know what to write down from up here, write the whole thing. So we have quadrilateral, MATH, HM, congruent to AT, HT, not congruent, but perpendicular to MEA, and HA, perpendicular to AT. And then we need, these all need hats. And then given. Okay, so we got HM equal to AT, and we got HT equal to AM. Well, that's going to help us out, if you can see where that's going. Maybe you can throw it in the chat what we can do with that stuff. We also have HE, that's right here, is perpendicular to MEA, so remember that's going to get us those boxes right there. And HA perpendicular to HT, so that's going to give us another box like right over here. All right, so let's go the easy route. First thing I see, keywords or symbols are the perpendicular signs there. So remember those perpendicular lines are going to give us equal 90-degree angles. So get specific. This angle that's here, HEM, is not in the triangle, so we're going to kind of ignore it. We are going to talk about these two angles right here, okay, as the angles that are 90 and equal. So we're going to say angle HEA is equal to angle HAT, and that is equal to 90. Now, option 2 is to say they're both equal to 90 and then set them equal to each other for step 3. This is just kind of cutting that step out and just making it 1. And then we're going to say that perpendicular lines make equal 90-degree angles. Okay, so there's the first part. All right. What do we think about what else we could do here? Yes, nice. I seen perfect. So because we have these two pairs of sides, right, equal, that makes this thing a parallelogram. So we can say that MATH is a parallelogram. Okay, and then same thing, in a parallelogram, opposite sides are congruent, or opposites, if the opposite sides are congruent, right, our shape is a parallelogram. Any one of those things that you want to put down will work here, okay? All right, and then we need, and we can see it right in here, right? There is, between the two triangles, there's a Z going on right there, okay? So if we had these two lines parallel, that would get us those angles equal. So we need to get and show that this side, HT, is parallel to MA first, and then we can use the Z here to get those other two angles congruent, and then we'll be able to say that the triangles are similar. So 4, we're going to say that HT is parallel to MA. You could throw in, just because we can, MH parallel to AT, but we're not going to use it, but it's part of it. So if you wanted to toss it in there, feel free. Okay, and then we're going to write the same thing here except opposite sides parallel. So in a parallelogram, I feel like I wrote parallelogram. Opposite sides are parallel. And then we can get our two angles equal here. So now we'll be able to get the angles in the Z equal. So angle AHT or THA, your call, and angle HEA or EAH, HAE. And this is that long reason we always hate rating or love, depending on what you want to do. Two parallel lines cut by a transversal. And then the alternate interior angles are congruent. Okay, and now we have the last three steps here. So we know that 6 is going to be the triangle is similar to the triangle. 7 is going to be our proportion. And then 8 we know is going to be our proof statement. TA times HA equals HE times TH. Okay, so 6 is always going to be our AA, Similarity Theorem. And then we have to name our triangles. So remember, look at your triangles and look how the angles are kind of ordered. We have a right angle, we have one arc, and we have no arcs. So if we want to call this EAH in that order, we have to do the second one in the same order. So right angle, one arc, no arcs, okay? And that's going to be AHT. So as long as you put it where you have E and A in the same spot, A and H and T, you're good to go. So if you said AHAE, it'd be THA. Okay? Then think about it for a second. You can kind of get the idea that if you put the sides with T's in them underneath, so if I bring this TH, right, from this side here and bring it under here, okay, and then I'm going to bring the sides with the H's underneath and bring this one back, that's how you can kind of get your ratio. Or anything that when you cross multiply, you end up here. So if we write TA, and then we're going to bring this second one underneath over TH, and then keep one on this side that's HE, and we'll move the other H underneath HA. And then just double check. TH times HE is right here. TA times AH is right here. Okay? Remember that this one is kind of the also like CPCTC, but we can't abbreviate. So corresponding sides in similar triangles are proportional. All right. And then 8 is going to be now the formal math term is product of the means is equal to the product of the extremes. We're kind of getting away with the multiplication property of equality because we're multiplying both sides by the same amount. This side by TH to get rid of the THs, this side by HA to get rid of the HAs. To get there. And that's it. There is our proof. Okay. So, let's take a look at the the points here. And you're going to see 6 points, right? Proof's done, everything's correct, everything's included. Complete correct proof includes a conclusion is written. Okay, step 5, thorough understanding, but no conceptual errors. That means like you didn't use the wrong reason somewhere, you didn't assume something that wasn't right. If you said it's a parallelogram, you gave the right reason, that type of thing. One statement and or reason is missing. So it kind of means like if you did something but you forgot a step along the way, maybe you put this down wrong or got an incorrect, like in a parallelogram, opposite sides are, or something, or you just said it's a parallelogram but didn't expand upon it, that would be where you might lose a point there. Okay. That is the wrong one. So 4 points. Okay. No conceptual errors. 2 or more statements and or reasons are missing or incorrect. So it could be 2 of the same step or 2 separate steps. Okay. Notice that as long as you got the triangle similar, you got 4. Not bad. All right. If you made a conceptual error, that's 4. We talked about that using like the wrong concept or thinking ideas. If you had 3 statements and or reasons missing, okay. If you made a conceptual error and had a statement kind of missing, get the idea here. If you had enough work to get the 2 sets of angles equal, but no other work, that's 2. And as long as you had 1 correct statement and reason written, you got a point. Okay, remember, told you, 0, you get nothing for doing the given and the proof. Okay, so as long as you get 1 statement and reason in there, you're getting yourself a point. So always try to build at least to that, so that we're at least getting those amounts that we're looking for here. All right. Any other questions on here that you would like to continue to go over? Or anything on part 1? If you had a chance to look at the exam and were confused on anything? If you want, I'll just go through the answers and you guys can write them down for yourself. And then if you want to take a look, we can take a look at them that way as well. So why don't we do that? I'll just give you the answers here as we go along. And then if you have a question on something, let me know. Okay, you this way. All right. Multiple choice answers. Oh, man. Okay. Let me just pull up these answers real quick, run through them. Number 1, which rigid motions are going to take our triangle? Notice and pay attention to the order. So it's a reflection, okay, followed by a rotation, turning this way, okay. So a reflection followed by a rotation. Choice number 3 there for credit. Number 2, using the table below, which country has the greatest population density? Remember, that's population divided by the area is going to give you your population density. And then you're just picking the correct number here. 2019. All right. So that's going to be choice 3, Niagara, when you divide those out. All right. So population over area for that one. Choice number 3, if a rectangle is continuously rotated around one of its sides, that is going to make ourselves a cylinder. And then I'm just going to highlight these as we go, in case anyone goes back and looks at these. All right. So we said a reflection, followed by a translation. Oh, sorry. We said 3. We talked about it being a rotation, and then I highlighted translation. All right. 2 we said was Niagara. 3 is a cylinder. All right. For number 4, should be 4. So which transformation carries the parallelogram down itself? If we reflect over the line y equals x, that's going to go this way. The parallelogram doesn't fold onto itself because the diagonals aren't equal and they're not perpendicular. So t is actually going to end up over here somewhere. Same thing with y equals negative x. These two don't fold onto each other. All right. And if we rotate counterclockwise about the origin, 90 degrees, that also doesn't work. A does not go directly where M is. It's going to be off to the side. But if we turn it upside down, what I would recommend you do for this one is if you go 90 degrees, just turn your paper. Does it look the same? Like it's not going to look exactly the same, but upside down, it will. Okay? So think about kind of folding your paper over and see if that's going to do it as you're going along and see if that works. All right, number 5 here. So after dilation mapping, which of these coordinates, what is the scale factor? So if you just do the x's or the y's and make a ratio from C to C prime, okay, remember it's always, is it getting bigger or smaller? So it's getting bigger. Okay, so we're going to do prime over the original, so image over the original, and we should get 3 over 2. So that's choice 1. 6. Plug in your formula. Okay, should be 128. For number 7, you guys will have graph paper. You can graph the line. You can also graph it on your calculator. Take a look at the grid. See if it passes through the origin. Okay, so if you take your calculator for this one, what's up, Charlotte? Oh, no, go ahead. No worries.
Thank you for having us.
Yeah, tomorrow, same time, if you'd like to join. Okay, so if you want to type in the equation, so it's negative. Now, what I would do if I were you is delete the equal sign, choose relation, okay, and then type in the exact equation. So negative 3x plus 4y equals 8. Hit enter, okay. Oh, no. All right. You can add, if you remember, going to view and then grid, line grid. We can view the grid here. So if we dilate, which could be, now could be just means what's the slope? Because remember, they're supposed to have the same slope. So if you look at the line, any dilation we do is going to have the same slope. So if you count, we're going, here's one point right here at the point 0, 2, and it looks like there's another point right there that's going right through whole number coordinates, and that is 1, 2, 3, 4. 1, 2, 3, 4, 5. So we're going up 3 to get there, and then over 4. So that's 3 over 4, and then we're going to pick anything with a slope of 3/4. We didn't even do anything else. It's got to be choice 2. We can use our calculator to do it. Okay. You also just press tab and type in the answers. Okay. Y equals 3 over 4. X plus 8. Hit enter. Is it parallel? That's my answer. Okay. So keep it simple here. All right. Number 8, which transfer information is always sufficient to prove that these are going to be congruent? We did this one in class for another question. That's going to be choice 4, that the lines bisect each other because we're going to have vertical angles in the middle. Remember, the sine of one angle is always equal to the cosine of its complement, means it adds to 90. So it should be choice 2. 57 and 33 make 90. Don't pick the same one. Okay? 10, volume of the hemisphere has a diameter. It's 4 pi r squared. Cut this in half and plug it in. All right? And then we can choose our answer. That should be 1. All right? Number 11 underneath. If it says that these two are points, what is the length of BC so they're parallel? That's a side splitter theorem. So we can just do our ratio and proportion. So label your triangle, 5 over 12, 7 over, and they want to know what is BC. Oh, we are frozen. No. All right, if we're logged out here. We're going to get back in a second. All right. So 7 over, and they want to know what this whole side is. So you can just do a ratio like this. Call this x. Okay. What's up, Genevieve? Call this x, and then you're going to need the whole thing here. Okay. So you can do, for example, 5 over 17, 7 over x, and then you can cross multiply and south. But you should get choice 1 as an answer. We're having some issues here. All right. Instead of me doing that, I'm just going to bring over the answers here. So here's a copy of the answers. We're going to roll through this instead because it's whenever I write on the OneNote, it's getting very laggy. So I'm kind of losing the ability to do that here. Okay. How about we work? Come on. All right. So same thing. Okay, you could do 5 over 12, 7 over x, and just make sure you add that 7 back onto your answer. So it'd be choice 1. Quadrilateral must be a parallelogram if, choice 3, one pair of sides is both congruent and parallel. If one pair of sides is parallel and one pair of angles is congruent, that is definitely not enough. One pair of sides is congruent and one pair of angles is congruent is also not enough. Okay. Diagonals are congruent is a rectangle. All right. Number 13, your circle property here. So remember, we're just multiplying part times part here. So you can label and go through, and you should get which of these is equal to the same thing when you multiply. So if we do 8 times 15, which of those is equal to 8 times 15? It should be choice 3. Number 14, remember, which of these would not? Remember, we're not choosing our bad language right here, right? Angle, side, side. I would highly recommend that you just draw a picture, label these, and then you can pick out which one is going to be the same. For number 15, you need to redraw the triangle here. Flip it back upside down, to make your ratio. So this side that's 4, okay, is actually corresponding to x, and the 9, okay, is corresponding to the 6. And then you can cross multiply and solve. All right. Number 16, we did our point slope form. So solve for y here to get the slope, or type it in your calculator. Okay. All right. You can type this line, and you can type all these answers in your calculator, and you can just match the one that passes through the 0.13. Remember how to get the grid on the calculator? We talked about that. You do menu, okay, view, grid, and then you pick your line grid, okay? So once you graph your answers here, you can just see which line is going to be parallel and passes through that point. That'll be nice and easy to do. 17, when the rhombuses are intersecting, they bisect and create a right angle. So you're using Pythagorean Theorem. You should have got choice 2. 18, we have our big arc minus small arc divided by 2. So that should be choice 1, 19. Number 19, partitions the segment 2 to 1. So remember, we're doing the change in x, the change in y. This is a ratio of 2/3. So it's net the difference here, or how to get from negative 8 to 10, okay, is 18 times 2/3, and then add it to negative 8. So that should give you x coordinate of 4. From 4 to negative 2 is going down 6 times 2/3 is 4, negative 4, and then plus 4 gives you 0, and you should have choice number 4 there. Okay, remember we talked about how to do this question on your calculator, number 20. So you can take your graph, okay. If we want to delete these guys, we can, just to get them off our grid. All right, we're going to go to menu and then smash the 3 button. 3, 3, 3, and we're choosing standard form, which is choice 2 from there. Okay, we're typing in, so we can see it's 1x squared, which gives us 1y squared. Tab it over the x, that is an 8. Oh, 1, tab, 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 untab, is 8. Where the y is, okay, is negative 12. So we're going to put a negative 12 in here, or a minus 12, really. Oh, that needs to go there. And then the last number, I believe, was 144. Okay. And then we can go ahead and hit enter. It'll bring us our, I'm going to go back to I accidentally hit something. I'm just going to click standard so it takes us back here. And then if we did it right, it should graph our circle. And if it doesn't like us, we can always zoom out. All right, it doesn't like us. But that's how we can graph this, okay? I would say we probably need a new graph to do it. I don't want to keep you guys bored too long, but that's essentially how you're going to enter that in. So let's try it again. So menu, 3, 3, 3, standard form. Okay, so 1, we had 8, negative 12, and then we had 144. Oh, I see what it is. The 144 is on the other side. We have to subtract it over, so that's why it's not coming up. So this should be a negative 144, not a positive 144, and then I think we'll see it. So careful with that sign. There it is. Okay, you can always double click here if you want to make this bigger. So we can make this, let's say 10, and then you can see your center point. Remember, if it's hard to see, we do menu, view, grid, line grid. Now we can count. So it's -4, 1, 2, 3, 4, 5, 6. So that should be x. The center is -4, 6. This is the only ones right here. And then we can count, right? That's over 4. Okay. And then it's going over 11. So that should be the correct radius, or 3 and 11. So that's 14. Yep. Okay. Same thing in this one. Opposite angles equal. It's isosceles. The base angles are equal, so you can get this and then get that measure. So that's 80. 22. This is a Sohcahtoa question. So label, draw your triangle. Okay. 12-foot ladder, hypotenuse above the ground on this side is 10. The angle to the nearest to the makes of the ground is x. And then you're going to use your inverse function. So sine inverse of 10 over 12. And then you have choice number 4, which is 56. You can always type this in and then plug these in for x and see which one gives you the same ratio as well. Okay, this is a mid-segment question. Remember that this line EF is always half of line AB. So there's 2 EFs to make 1 AB, and then you can solve, and you should get choice 3. And the last one, not sufficient, is choice 3. The diagonals are perpendicular and one pair of adjacent sides is congruent. That will not make it a square. That makes both of those actually are properties of a rhombus. All right, I'm going to stop the taping here. We went through the whole exam. If you have any other questions, you can let me know.